All right, welcome back. I lied to you. In class, I told you that we would not need to know the t-test for the difference of two means. And then I went back and looked at the exam, and it is on there. So I'm going to do a video here. This video was uploaded about this material. So if you need to, it's the 4.3a material. But I'm going to walk you through a problem, sort of like we did in class today, to kind of talk about what you need to know for this. So let's start with it. Let's say this. So we've got a problem here. A sports equipment company wants to compare the durability of two different tennis ball brands, brand A and brand B. They randomly select 30 tennis balls from each brand and conduct a, this is not the problem that I was looking at. Oh yeah, that's fine. Oh, I forgot where I was. And conduct a test to measure the number of times each ball can be bounced before breaking. Below are the summary statistics on bounce number. The question here, do these data provide evidence of a difference between the mean number of bounces for brand A and the mean number of bounces for brand B? The result of a hypothesis test are given below. Assume conditions for inference are satisfied. So what I have is two different samples, some information on both. So we're going to walk through that test for the t-test for the difference of two means. So the data that I've gathered that is here is given to me here, right? This stuff. So the first thing that I'd want to do is this copy and paste function drives me nuts. The first thing I want to do is write the hypothesis using correct symbolic notation, right? So since there are two, I want to write this. My null hypothesis is that there's no difference in the number of bounces, right? Because I want to test to see if there is. So the null hypothesis is that the mu for brand A is equal to the mu for brand B, right? This could also be written as mu sub A minus mu sub B is equal to 0, right? Those are two equivalent statements. But there's a benefit to writing it this second way, and we'll see why in a moment. And so then my alternative would be that the two are not the same. So you might say mu sub A is not equal to mu sub B. Or likewise, we could say that that alternative hypothesis is that mu sub A minus mu sub B is not equal to 0, right? So that answers that first part. The second part here then says, what is the test statistic? In 85 billion point font. Still stupid. All right. What is the test statistic? Right. That is calculate t. Right. So I need to calculate t, and I have to have a couple of formulas to do that. Right. The first one is the t formula itself. The t value is the difference between my samples, as my sample means. So it doesn't matter which one I choose, xb minus x of a, right? Or if I want, since I've written a minus b, right, it might be nice to stick with that notation, but ultimately it doesn't matter because I want to know if there's a difference. It doesn't matter if that difference is positive or negative. So I'll write it though as sample A minus sample mean of B, and then minus the mu sub A, minus a mu sub b all over standard error, right? And it's this standard error that we'd want to take a look at. Standard error is given by this equation. The variance of 1 squared. So the variance, which is s squared, or the standard deviation squared, over n1, and then plus s2, right? The standard deviation of sample 2 divided by n2, right? So that is our standard error. That's what goes down there in that denominator, right? So that is then to say this value right here, right, according to our null hypothesis, is 0, right? We're under the assumption that that's true throughout the test. And so this simplifies nicely to be just your difference of your means over that standard error. So over the square root of s1 squared over n1 plus s2 squared over n2. Right? And I should have all of these values. The sample means are up there. So I'll just plug those in. Sample mean of A was 780. Minus the sample mean of B, which is 840. Divided by, my camera's in my way. There we go. The square root of standard deviation 1, or standard deviation of A, if you like. These should be like maybe A's and B's, since that's my right. So standard deviation of A was 121. So 121 squared over 30, because they chose 30 from A, but they also chose 30 for B, so that's kind of nice. And then that's 103 squared, right? And so I'm going to just throw that into a calculator. Try this out in your calculator that you'll use on the exam. But I get negative 2.06. And so that is my test statistic. That's my T, right? And then the next thing I'd want to do is figure out what the p-value is, right? But the p-value, oh, in fact, I did all this stuff. I don't know if I'm on drugs or what here, but that value is actually given to you. Oh, very nice, right? So in fact, I should have maybe read the damn question, because I didn't need to do all that work. It's given to me. It's right there. It's negative 2.068, which I got. I just didn't round it correctly in my here. But that's given to me, right? And in fact, the p-value is also given to me. So I didn't actually have to do all of this math. I could have just said, hey, look at that. There's my values. The p-value is 0.04, right? And so when they ask you in the next little bit here, what is the p-value? The p-value is given to you right there, 0.04, right? So that's 0.04. I don't have to calculate it, which means the likelihood of getting results of this nature, this big of a difference purely by chance, is about 4%. If the true mean of tennis ball brand A is equal to the true mean of tennis ball brand B. Since that p-value is less than 5%, we reject Going at the alpha of 0.01. Oh, all right, 0.01. I'm not going to be able to reject this anymore, right? At this significance level, I don't reject it because my p-value is not less than my significance level. So I'm not going to reject it, right? If the question had been at alpha of 0.05, which is typical standard, then I would reject. I do reject at an alpha, a significance level of 5%, right? So know the difference, right? But know that on this question, even though I started doing all this math, I didn't need to because I'm dumb and I don't read questions before I jump into them. Those values are given to you. The p-value is given to you. I don't need to run this whole test myself. I just need to interpret this data that's right here given to me, right? So know that, be able to just interpret this. And then the last little bit would simply be, oh my gosh, write the appropriate conclusion and context of this problem. Well, in the case of the question where it says the alpha of 0.01, you just need to type up something or write up something that says at, right, maybe make it bigger, at a 1 alpha of 0.01 significance, we, what did we do? Fail to reject. Or we would do not have enough evidence to reject the claim that the average number, I'm not going to type this whole thing. The context of the problem is that the average number of ball drops of a ball, tennis ball brand A, is different than the average number of drops of tennis ball B before they break, right? So again, you can go through this math, right? But for the test, you don't have to do all of those questions, all of that math. You just need to be able to interpret this output, right? It'll say this output was given by a calculator, and it doesn't matter how you got it, it's right there, right? And so we have it, we just need to interpret it. Bam, that's how we do it. Okay. Thanks. Bye.